So Alex and I on Lab 2 decided to go with a rotating movement so that it would keep going as it went towards the goal. This made it very easy for the robot to follow a path without having to stop to correct its direction. It made it very easy to follow a specific tag. Also, it had a pretty good turn radius, especially after we adjusted some of the parameters. It could get to its direction even faster than this video shows. This was one of our slower turn radiuses, but as we kept adjusting, it was able to get to those paths pretty quickly. One thing to keep in mind is that according to the camera, the robot's actually a little bit further down than it would want to show. It elevates the tag, and so the pixels for the tag are actually further up in the Y space than the actual robot is on the ground. So this leads to a little bit of error that comes from this misalignment due to the elevation of the robot and the angle of the camera. We also were able to get a repel tag to work. Again, it responds a little late. That's because of the delay in the camera, and also again because of the elevation of the robot, but eventually it's able to correct its course and get back around to the goal tag. Again, we continue to work on field values and turn radiuses in our parameters. This worked especially well once we were able to plot the potential fields using matplotlib, and this allowed us to correct those values and get the robot to respond even better to the repel objects and to get to the goal object even faster. We also made a wall object, which allowed us to make some more complex obstacle courses. This would keep the robot from straying too far away, especially out of the camera's view, and it just basically pushes the robot back into the field of view. For the creative part of our lab, we decided to go with a location prediction algorithm. We found with the camera the lag was really bad, especially when the robot was moving at high speeds, which got the robot a little too close to some of these objects. And we decided to use a simple forward propagation method of just basically predicting the object's speed to determine where it would be if the camera was refreshing at a fast enough rate. And this led to some very good results of the robot turning in physical space even before it was being seen in camera space because it was forward predicting its location. This led to a couple of problems, one being that it never really got too close to the goal because its speed would slow down before it actually got there. But overall, it allowed us to deal with the camera lag, and it was able to navigate really well before it hit those objects. Now, to keep in mind, this is not a full Kalman filter. It's just a simple vector multiplication based on the current speed of the robot and where it is in the field. But this also allows us to get some really complex obstacle courses where it was able to navigate pretty well around those objects and get to the goal because of this forward propagation. Now, however, this did lead to problems if the objects were really close, because it would think it was in one part of the field when it wasn't, and so closely grouped objects caused our robot to behave very strangely if we had the forward predict on. As you can see, it's very sporadic in its movements and never really gets to the goal and stops. We were also able to correctly navigate our partner group's obstacle course for us. However, at the time, our partner group was not finished with their code yet, so we could not give an obstacle course to them.